Hello mathematicians, thank you for joining me as we try to find the limit as x goes to 2 of x squared plus x minus 6 all over x minus 2 algebraically. And so now we had looked at how to do these graphically, we've looked at how to deal with piecewise functions, and so now we're looking at functions that might have some type of discontinuity to them. Now what we've already decided in class was that if this is a continuous function, I can just plug in and get out an answer. So the first thing I want to do is I want to plug in 2 and evaluate the inside function at 2. If I do that, I get 2 squared plus 2 minus 6 all over 2 minus 2 is equal to, well, 2 squared is 4 plus 2 is 6 minus 6 is 0. All over 2 minus 2 is 0. So we get 0 over 0. Notice that we cannot divide by 0. Therefore, the function is not defined at the point 2. So this function would be discontinuous at 2 because it's not defined. Now, what we want to do is we want to say, well, can the limit still exist? And what we've seen is that when we get 0 over zeros, this is what we called an indeterminate limit. That is, we don't know if the limit exists or not, and so what we're going to have to do is more work. In this case, we have a rational function, and so the trick here, or the technique here, is that we can actually factor the top and bottom and hopefully cancel something out. And so what I'm going to do is I'm just going to rewrite this as the limit as x goes to 2 of, well, what does x squared plus x minus 6 factor into? So I need numbers that multiply to negative 6 and add to positive 1. So I think that's positive 3 and negative 2. And so I get x plus 3 times x minus 2 all over x minus 2. As a helpful note here, sometimes this factoring can actually be difficult and it's hard to figure out what they're going to be. A lot of times it makes it easier on me if I realize that, well, I already plugged 2 in. Because I got 0 over 0, which is the whole reason why I'm doing this, I know that because I got a 0 in both of these, x minus 2 is going to be able to factor out of both of these. So if I know this term is going to be x minus 2, finding this term is a lot easier because I don't have to worry about finding combinations that multiply to this and add to this. I just have to say, what do I have to multiply negative 2 by to get out negative 6? And so a lot of time that'll save me a lot of work. Now, the next thing I want to notice is that, well, what I have here is x minus 2 over x minus 2. So let's take a quicker look at that, or a deeper look at that. And if I have x minus 2 over x minus 2, notice that what I get most of the time is just 1. If I plug in x values like 5, I get 3 over 3 is 1. 6 is 4 over 4 is 1. And so basically if I plug in anything, I get out 1, except if I plug 2 into here, I get 0 over 0, which is undefined. So what I'm going to say is that this is equal to 1 if x is not equal to 2. So when x is equal to 2, these are not equal. So I can't say that these are equal in general, but I can say that these are equal as long as x is not 2. Now the nice thing is because we're looking at limits, remember limits are defined as what happens as we get close to but not equal to 2, is I can say that, well, I don't actually care that these aren't equal at 2 because I don't care what happens exactly at 2. I only care what happens as I get close to 2. Therefore, when I'm working with a limit, I can actually say that because I'm getting close to but not equal to 2, the x minus 2 over the x minus 2 will cancel, and I'm just left with x plus 3. So now what I was able to do is notice that because I don't care what happens exactly at 2, I can cancel these terms out, and now I'm left with a new limit. And so if I want to find the limit as x goes to 3, I start my process over again. And so I would say, okay, the limit as x goes to 2 of x plus 3 is, well, I want to plug 2 in. If I plug 2 in, I get 2 plus 3 is 5. Because I get a number, I know that x plus 3 is continuous at the point 2. So therefore, this limit is equal to 5. So this original limit is equal to 5. And so with a rational function, I was able to factor the top and bottom. I was able to cancel a term out where it's going to be of the form x minus c, where c is the number we're getting closer to. And we can do that because it's not going to be equal to that number. Then we're left with the new limit that we can calculate, and then we'll have to plug in to figure out what that's going to look like. So we now have our limit. Thank you for joining me today, mathematicians. I hope you enjoyed this, and I hope you learned something along the way. If you did, make sure to like the video and to subscribe to the channel down here. This will help make sure that other people get to find this video so that they can also get help on calculus.